Graph the solution set to a system of linear inequalities. To begin with, a system of linear inequalities is a set of two or more linear inequalities. So an example could be something like 2x plus 3 is greater than y, and negative x plus y is less than or equal to 6. The solution is the region of the coordinate grid that satisfies both of the inequalities at the same time. So when we graph these systems of linear inequalities, first we want to graph each inequality separately. So as we graph the inequality, we want to shade what side or make note of what side of the inequality should be shaded. And then wherever those two shaded regions overlap for the inequalities, that's our final solution set to the system of linear inequalities. So let's do a couple examples together to make sure we understand. So let's start with this system. We have negative 1/3 x plus 2 is less than or equal to y, and 2x plus 8 is greater than 4y. So let's start, we're going to graph our first inequality. So let's put our y-intercept. Let's use our slope to graph the rest of our function. Let's see. Okay, and I can see that my inequality symbol is less than or equal to, so I'm going to use a solid line. My last step is to choose an ordered pair on the coordinate grid and test it to see if it makes it true. So I'm going to choose the point 0, 0. So let's see. We would have negative 1/3 times 0 plus 2 is less than or equal to 0. That means 2 is less than or equal to 0, which is not true. So 0, 0 would not be part of this solution set. So I'm going to shade above the line here. And that would be my solution set for my first inequality. I'm going to change colors for my second. So now I have 2x plus 8 is greater than 4y. So let's divide everything by 4. I get 1/2 x plus 2 is greater than y. So let's put our y-intercept. Let's use our slope to graph the rest of our function. Oops. Okay, I see that my symbol is greater than. It doesn't have the equal to part. So this line is going to be dashed or dotted. We can choose a point to see if it makes it true. Again, I'm going to choose the ordered pair 0, 0 just because that's simple. So 1/2 times 0 plus 2 is greater than 0. I see that 2 is greater than 0. That satisfies. So everything below the green line makes that linear inequality true. So now my last step is to figure out where do these two inequalities overlap. I see that that's happening right in here. So I want to shade in that as my solution set region. So this section right here would be my solution set to the system of linear inequalities of negative 1/3 x plus 2 is less than or equal to y, and 2x plus 8 is greater than 4y. Okay, let's try one more example together. Let's see. So for example 2, we have the first inequality is negative x plus y is greater than 6. So let's figure out, we have negative x plus y is greater than 6. I want to switch out my x and my y. That way I can graph this in slope-intercept form. So now I have x plus 6 is less than y. So we're going to put our y-intercept. I'm going to use my slope to plot the rest of my function. Let's see. I see that my inequality symbol does not have the equal to part. So this is going to be a dotted line. It's not going to be a solid line. I want to choose an ordered pair and see if it makes the equation true. So I'm going to choose the ordered pair 0, 0. Negative 0 plus 0 is greater than 6. That is not true. So I'm going to shade above the line because the ordered pair 0, 0 is not part of my solution set. Okay, let's graph our second inequality. So now we have x plus 3 is greater than y. So here I have this. Let's see, I want to go use my slope to plot the rest of my function, I see that these two lines are going to be parallel because both functions have the same slope. This line is going to have a solid boundary line because it's greater than or equal to. And now I want to choose an ordered pair, see if it makes the equation true. I'm going to try 0, 0. So let's see, 0 plus 3 is greater than 0. That makes the equation true. I'm going to shade below the line because 0, 0 satisfies the equation. I see here that I have no overlapping regions of the coordinate grid at all. So in this case, I would have no solution to this system of linear inequalities.